Hello, Honors Algebra students. Mr. Lawrence here, and this is your review for chapters 10 and 12 as requested by Matty Gatos. All right, first of all, how about adding and subtracting matrices? Remember that the matrices need to be the same size to add or subtract them, right? And it's just as simple as adding the pieces in the same places. For example, I'm going to add, where's my highlighter? I'm going to add a 2 and a -5. Why? Because they're in the same position of the matrix. So similarly, I'll add 8 and 1/10 to 3, etc. So, and by the way, at any time, if you want to pause the video and try this on your own, you go right ahead because this stuff's so simple. So I'm going to get a -3. I'm going to get 11 and 1/10. I'm going to get a 2 and 7/10, I believe. Here I'm going to get a 9. Then I'm going to get a -4 and 3/10, and finally a 0. Right? There's the new matrix. The sum of the two matrices is that. All right, if you want to try the second one here on your own, it's subtraction. Here comes my solution. 6 minus 5 is going to be 1. -8 minus -8 is going to be 0. -10 minus 6 will be -16. And finally, 12 minus -3 will be a +15. And there you go. All right, that's it. Now, adding, subtracting matrices, pretty simple stuff. I'm going kind of quick, so this video doesn't take too long. All right, here we go, the Pythagorean Theorem. We talked about the Pythagorean Theorem. And remember, we did learn two special triangles, right? There was the 30, 60 90 right triangle, in which case we had the hypotenuse being twice as long as the shortest leg. So it was like 1, 2, and the square root of 3 was the intermediate leg. If you notice that, you can go ahead and figure out the sides without using the Pythagorean Theorem, but knowing the Pythagorean Theorem is awesome. There was also the 45, not a 44, 45, 45, 90 triangle, in which case it's an isosceles right triangle, right? These are the same, and that was like 1 plus 1 is the square root of 2 in proportion. But again, if you don't remember that, you can use the Pythagorean Theorem. All right, so look at this one here. I'm going to use the Pythagorean Theorem on it. Now remember, it's a squared plus b squared equals c squared, where c is always the hypotenuse, not always the side we're looking for. It's always the hypotenuse. You may want to fill in the hypotenuse first to make sure you don't make a silly mistake. Okay, and then I'm going to go x squared plus 5 squared. And so I'm going to get x squared plus 25, and that's going to equal 100. So x squared is going to equal 75. And that means that x is going to be the rad of 75. And simplified, I should get, let's see, that could be 25 times 3. And so we're going to get 5 rad 3. That would be an exact answer, right? Of course, I could multiply 5 times the square root of 3 and get the decimal approximation. By the way, excuse me, this looks like a 1, 2 rad 3. So I could have just taken 5 and multiplied by rad 3. Yeah, the 5 from here and multiplied by rad 3, and I would have got the same answer. All right, this one here isn't a special triangle. So I'm going to go 6 squared plus 7 squared. And that'll need to equal x squared. Why is x the variable? Because it's across from the right angle. All right, so what do we have here? 36 plus 49 plus x squared. That's going to be 85. I don't know if that's going to simplify. I'm thinking not, but I'll take the square root of each side to see if I can. And so I'm going to get x is equal to, let me see, 5 and 17. Yeah, that's not going to simplify because the two factors are prime. So I could do that, or I could go with a decimal approximation. It's going to be a little bit more than 9, but you can punch that in a calculator. All right, so one more Pythagorean Theorem problem. What would the Pythagorean Theorem be without a story problem? So an airplane flies 27 miles due north and turns due east and flies another 35 miles. Now, I don't know why, but my honors kids, you guys, don't seem to like to draw cheesy little pictures. But I'm telling you, they make the problem simple. All right, there's my right angle. I know my picture's off a little bit, but I'm not being graded on my artwork. The question is, whoa, what the hookah waka is that? So let's see here. All right, there's my right triangle. I want to know how far it is from its original position. This would be the shortest distance. So I'm going to do 27 squared plus 35 squared. And that's going to equal x squared. All right, so 27 squared, I don't know off the top of my head. 27 squared is 729. Oh, I should have known that now that I see it. All right, plus 35 squared is 1,225. That one I do know. Equals x squared. I'm going to add 1,225 to 729, and I come up with 1954, a very good year. All right, x squared. I take the square root of both sides. Okay, and so x is going to be approximately equal to 44 and 2/10. 44 and 2/10. All right, whatever the units might be. I guess it would be miles, right? The airplane hasn't flown 44 and 2/10 miles. The airplane is 44 and 2/10 miles away from its original position. All right, so let's go to the next problem, simplifying rads. Remember that to simplify these, you want to break the number down into the largest square root, largest perfect square factor that it has. For example, I would break 600 into 106, and I would rewrite it as the square root of 100 times the square root of 6, which would be 10 rad 6. There we go. The square root of 96, well, let me see, I know 4 is going in, but I don't think 4 is the largest perfect square factor. Let me go through my perfect squares and see which ones works. So let's try. Let's see. 81 is the largest perfect square that's not more than 96. That doesn't work. 64, that's not a factor. 749, 98, no, that's not going to work. 36 is not a perfect square, or not a factor of 96. 25, no, that's not going to work. 16, that's an interesting one. Let me see, 16 times 6, yeah, I think that's going to work. 16 times 6, so, yep. So I'm going to have the square root of 16 times the square root of 6, and it should be 4 rad 6. Now, by the way, that's just a coincidence that they're both rad 6. But since I have 10 rad 6 and 4 rad 6, you know, I could kind of blend into something else. What would happen if I added these two answers together? Well, they're both like terms. Why? Because they're both rad 6s. So I could add them together and get 14 rad 6. And there you go. All right, we also need to know how to rationalize the denominator. Right now I have an irrational denominator on this problem. I can't simplify these 6's because that's a 6 and that's the square root of 6. But I can multiply by 6 and multiply by 6 here because I'm really only multiplying by 1. And so I'm going to have 6 and then rad 3 times, hey, wait a minute, can't I think about 6 as rad 3 times 2? Rad 2, right? Rad 6 is rad 3 times rad 2, and that would be over 6. Oh, this becomes a real easy problem. Watch what's going to happen. First of all, this is all multiplication in the numerator, so these 6's will cancel. Rad 3 times rad 3 is 3, and then there's this rad 2 coming along for the ride. And there you go. It's 3 rad 2. All right. To take care of this one, I'm going to multiply the denominator by 3 minus the square root of 2. And if I do it in the denominator, I'll do the same thing in the numerator. 3 minus the square root of 2. All right, so distributing the 7 will get me a 21 minus 7 rad 2. My denominator, I'm going to get a 9. right? And a 3 rad 2, but a negative 3 rad 2, they will cancel. And then finally a minus 2. So my answer is going to be 21 minus 7 rad 2. That's over 7. Ooh, I can simplify even further. I like this problem. If you look in the numerator, there's a GCF hiding in there. There's a factor, a common factor. Don't they both have 7 as a factor? The new 21 could be thought of 7 times 3. And the rad term, the irrational number, is 7 times the square root of 2. So you see they all have a factor of 7 hiding in there. Therefore, I can cancel out all 3 7s. I can go that, and that. So the best answer, the simple answer is 3 minus the square root of 2. And there you go. All right. How about these problems here? Well, some of you are thinking with 7 rad 5 plus rad 20 that they aren't like terms, and therefore I can't do anything. Au contraire, mon frere. All right. I can change this, can't I? Can't I simplify this? Wouldn't that be rad 4 times rad 5? And therefore it would be 2 rad 5. And now they are like terms, and so I have 9 rad 5. And there you go. All right, this one here I have to double distribute. 6 minus 2 rad 3 times quantity of 6 minus 2 rad 3. Right? Let me make that look more like a 3. There we go. So I'm going to double distribute. So I'm going to get a 36. Let's see, I'm going to get a negative 12 rad 3. So I'm going to get a negative 24 rad 3. Why 24? Because this will get me negative 12. And these two will get me negative 12. Excuse me. All right. Finally, I have a negative 2 rad 3 times a negative 2 rad 3. Well, it's going to be a positive 4 times 3. That's going to be a positive 12. Combining like terms is going to get me 48 minus 24 rad 3. And there you go. All right, this one here, let's see. I'm going to do each part. I'm going to have 5 times rad 15, and then I'm going to have x to the 6th times x, and then I'm also going to have y to the 7th times y to the 9th. Well, I'm going to think about this as rad 5 times rad 5 times rad 3, and so I'm going to have a 5 and then a rad with a 3 in it. Here, this is a perfect square, so that's going to be an x cubed and then a plain old x. Here, I'm going to have y to the 16th, which the square root of is y to the 8th, and nothing's going to be left inside, and there you go. All right, let's move right along here. Frequency tables and histograms. Well, let me see here. To do my frequency table, I got to decide how many numbers I have and what ranges I want to use. So it looks like the smallest number is 3, the largest number is 20, and that looks like it's going to be a range of 17. All right, I think I'm going to, if I use 16, that won't work. I'm going to go maybe 18 and go every 3. Yeah, so I'll have six range. Oh, maybe I'll go 3 of them. No, I'll go 3. Okay, so my first range is going to go from 3 to 5, right? Okay, and how many numbers are there from 3 to 5? Let me tally them up. So 1, 2, 3, 4. It looks like there's going to be 4. The next range would go from 6 to 8. And so there's going to be 1, 2. Right? And then we're going to go from 9 to 11. And let's see, there's going to be 1, 2, 3. Excuse me. Okay, 12 to 14. So let's see, 1, 2. Okay, 15 to 17. 15 to 17 will give me 1, 2, 3, 4. And then finally 18 to 20 is going to get me 1. All right, so when I go ahead and make my histogram, I think I might do it on graph paper here. All right, just so I can, so let me see, I'm going, 4 is the most, so let's make that 1, 2, 3, and 4. And then the first range will be from 3 to 5. So let me see here. I gotta get to 21, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let me go. Is it 1, 2, 3, 4, 5, 6. Okay. And so this is going to be from 3 to 5. This is 6 to 8. 9 to 11. 12 to 14. Where am I at here? 15 to 17. And then finally 18 to 20. All right. So my bars, the first range had 4, then 2, 4, 2, and 3. Okay, so 4 is going to go, it's going to go like that. 4, 2, and 3, so then this one will go here. And then up to 3 there. Okay, 4, 2, and 3. And then 2, 4, and 1. So I'll have 2, and then 4, and then drop down to 1. And it's going to look kind of like this. All right, with the airliner, it's how to draw the perfect segments, but that will be the idea. Okay, so there's my histogram. All right, very good. So let's move right along here. And finally, we have mean, median, mode, and then box and whisker plots, and then I will wrap this video up. All right, so this is data for the number of cars watched. All right, and so I'm going to find the mean, median, and mode, and then I'm going to decide which is the best. So best representative data. So let me see here. The smallest number appears to be 21, and okay, then 36, putting them in order, 42, 44, right, I think 45, oh, by the way, they're being watched the past 12 days, 50, 52, 67 shows up twice. Oh, I missed one, didn't I? I missed 55. Not a problem. Let's see here. Let me just take care of that. Let me put a 55 right there. So that's going to be 55. I need a 67 to show up a second time. And then I need a 71 and an 86. All right, 71, 86. All right, what the heck is that? Not 186, Mr. Lawrence, just 86. Okay, so the mode of this data, the mode is going to be 67. Do you think 67 is a good representative of the data? I would say not. because it only represents really 2 of the 12 numbers. I mean, none of the other numbers are even in the 60s. 71's kind of close to it, but if I was trying to base a prediction on how many cars would be washed one day, I would not use the mode. All right, the median is easy. There's 12 numbers, so I go 1, 2, 3, 4, 5, 6. The median looks like it's going to be 51. How did I get that? I averaged it. So the median is 51. All right, now let's see what the mean is, or the average. So I'm going to have 21 plus 36 plus 42 plus 44 plus 45 plus 50 plus 52 plus 67 plus 67 plus 71 plus 86. And I will divide by 12. And I've got 48. My mean is about 48 and 4/10. Okay? Now, which one would you pick to represent? Now, the median's kind of nice, except 51 to 21 is 30, and 51 to 86 is 35, so it's not smack in the middle of the range, because the range goes all the way from 21 to 86. The mean is 48 and 4/10. You might want to pick that one because it accounts for the outliers. The endpoints, the minimum value and the maximum value, are actually almost the same distance. So they kind of cancel each other out. So I think I would probably go with the mean because a good portion of the data falls near it. Perhaps the median is better because there are 3 numbers in the 50s. There's some numbers in the middle 40s. You know, you can make an argument either for the median or the mean. I think the mode would be a poor choice in this problem. All right, let's see here. I think there's one more thing I need to do, and that's to make a box and whisker plot. Oh, no, percentile rank. Yeah, I've got 2 more things to do. All right, so I'm not going to do those. I must have left it off. All right, tell you what, let's go ahead and make a box and whisker plot of this data, and let's see how it ends up looking. So the median we've already found was here, right? Now I find the median of the first half of the data. It's going to be 43. The median of the second half of the data will be 67, right? Okay, 43. And there's my box and my whisker. I'm sorry, would go like this. And the other way would go like that. Okay, so now let me make a better one. So let's see here. 43 is going to be the first quartile, right? And 67 will be the third quartile. Now let's decide where that median goes. Is 51 closer to 67 or closer to 43? I think it's closer to 43. It's only 8 away. The other one's 14, so it's almost 2/3 farther. So in the ballpark. So there would be my median, which is 51. Now, we said before that the distance here would be 30. I guess I've got to go a little bit longer than that to make it somewhat proportional, right? But over here, it's actually going to be a little bit longer because it's 35. And so let me try to go a little bit longer. And there you go. There's my box and whisker plot. All right, so the last thing I want to talk about is the percentile rank. Now, this is really easy. On a percentile rank, 3 of 26 students earn less than 80 or equal to 80%. What percentile rank is 80%? So 3 divided by 26. And then I'll multiply that by 100. And so if I do 3 divided by 26, I end up with like approximately 11.5 is the percentile rank. All right, that's what you can expect to see on Wednesday's test. Any questions, please come see me. Mr. Lawrence signing out. Have a good night, everybody.